A lot of the time when installing networks, you may just install a flat network, one subnet range, a gateway of 192.168.1.1, and then a DHCP pool range of 192.168.1.2 through to 80, for example. There's nothing wrong with that at all, and when you have a home with an ISP router, plug it in, connect all your devices, and then away you go. ISP routers are very, very basic and do not allow much configuration to shape the network and manage the traffic. So if you had a network with 30 cameras, 5 set-top boxes, 20 televisions, 50 mobile devices, PCs, games consoles and alarms, and so on, the network will soon become strained and the subnet range could become exhausted. So what can we do? Well, there are a few things we can do. Place all the devices into VLANs. Great, job done. General network VLAN that contains wireless devices, CCTV VLAN that contains all the CCTV elements, television VLAN that contains all the TVs, and so on. That is fine, but take for instance the CCTV camera VLAN. 50 cameras and a few network video recorders, 53 host devices for instance, 54 if you include the router. You have a subnet range that's scoped for 254 host devices, and you're using 54 addresses. That leaves 200 unused addresses. That's a bit of a waste of network resources. We could chop this subnet up into smaller subnets by doing subnetting. We can adjust the subnet mask and borrow bits from the host portion of the mask and give it to the network portion. So here we have a mask of 255.255.255.0, which is what we're all used to seeing. In binary, that equates to 8 ones in the first 3 octets and 8 zeros in the 4th octet. The zeros are the host portion of the subnet mask and the ones are the network portion. These are the binary values. On the right we have 1, then 2, 4, 8, 16, 32, 64 and 128. The host portion is what gives us 254 usable IP addresses. When you connect your phone or laptop to the network and you get an IP address of say 192.168.10.x, the X is the host portion that's allocated to your device. We can borrow bits from the host portion by adjusting the subnet mask, therefore reducing the amount of host IP addresses within a subnet. So I'd like to create a subnet that is scoped for 54 host devices only, that being the CCTV cameras and the router. Now, because of binary values, we can't just say 54 devices exactly, but we'll be able to find the next best value which we can work out. But first, let's discuss CIDR. Not that CIDR, classless inter-domain routing. This is the alternative method of displaying a subnet mask. You might have seen this on an IP address as say 192.168.10.0/24. The /24 is the CIDR block notation. This basically means the amount of network bits that are set to 1. So a /24 subnet mask equates to 24 binary ones set in the subnet mask, equating to a value of 255. So the subnet mask will be 255.255.255. So if we were to change the first bit in the 4th octet to a value of 1, that's now created a value of 128 for the network segment. So 1 followed by 7 zeros equals 128. So now our subnet mask is 255.255.255.128. How many subnets can we create with this mask? We can work that out by doing powers of 2. So 2 to the power of 1 equals 2. So we'll have 2 subnets. Then within that 4th octet, we have 7 host bits. So 2 to the power of 7, or 2 times 2 times 2 times 2 times 2 times 2 times 2 is 128. We then minus 2 from that total to account for the network and broadcast address. So that gives us 126 hosts per subnet. What does all this mean then? It means we have essentially cut this network in half. So the CIDR block is now 128. 128 and 128 is 256. 255 is the highest value you can create binary ones, but 0 is also a value. So to get from 0 to 255, if you were to count, would be 256. So we cut this network in half, and we now have 128 addresses in this subnet, ranging from 192.168.10.0 to 192.168.10.127. Remember, 0 is a value, so that is 128. We now have 4 important questions to answer. What are the network addresses? Network addresses are used to identify the hosts that are part of a network. What are the broadcast addresses? This is the address that is used to transmit to all devices on the network. What is the first and last usable host address? Like I said, when you connect your phone to the network and you look at the IP settings, we get something like 192.168.10.x. The x could be a number between 1 and 254 on a /24 network. So let's work this out. Network addresses. So we have two blocks of 128, 0 through to 127 and 128 through to 255. Just think of 128 as 0. So to get from 128 to 255, you'd be counting 128 times. The first 128 block has a 0. That's quite easy. Our network address is going to be 192.168.10.0. The broadcast address is the last IP address in the entire scope. That was 127. It isn't 128 because that's the start of the next subnet. So our broadcast address is going to be 192.168.10.127. To work out the first and last usable host addresses, we just add 1 to the network address and -1 from the broadcast address. So our first usable address will be 192.168.10.1 and the last address will be 192.168.10.126. Then in the next block, the network address is going to be 192.168.10.128. The broadcast address will be 192.168.10.255, and then our first and last usable addresses will be 192.168.10.129 and 192.168.10.254 respectively. So a nice and easy start, but 126 usable addresses is still too many for us. So let's quarter this block. We can then borrow another bit from the host portion of the subnet mask. So to remind you, we currently have a subnet mask of 255.255.255.128, which equates to 8 ones in the first 3 octets and a single 1 in the 4th octet followed by 7 zeros. If we add another binary 1 to the 4th octet, that now becomes 8 ones in the first 3 octets and 2 ones in the 4th octet followed by 6 zeros. In binary, that now equals 192. There are 26 ones or 26 bits in the network portion of the subnet mask. So the subnet mask will now be 255.255.255.192 and the side notation will be /26. Now we need to work out the amount of subnets we'll have and the amount of hosts per subnet. We can use the powers of 2 again. We have 2 binary bits in the 4th octet, which is being used for the network portion. 2 to the power of 2, or 2 times 2 equals 4. So we have 4 subnets that we can use. So what's the IP range within those 4 subnets? Well, let's refer again to the amount of host bits available in the 4th octet. We have 6 host bits. 2 to the power of 6, or 2 times 2 times 2 times 2 times 2 times 2 equals 64. So 64 addresses per subnet. Now we need to work out the network address, the broadcast address, and the first and last usable host address. So for the first block, that will be 0 through to 63. The network address for the first block, that would be 192.168.10.0, and the broadcast address would be 192.168.10.63. So why not 64? Because 64 is the network address for the next block. Don't forget, 0 is a value, so 0 to 63 is a count of 64. We then add 1 to the network address, so 192.168.10.1, and that's going to be the first usable host address. We -1 from the broadcast address to get the last usable address, 192.168.10.62. So we have 64 addresses in total, but 62 usable host addresses. We now have 3 other blocks, 64, 128, and 192. The next subnet is going to be 192.168.10.64, 192.168.10.127. The network address will be 10.64 and the broadcast address will be 10.127. We +1 to the network address and -1 from the broadcast address. The first usable address will be 10.65 and the last usable address will be 10.126. And then we've got the final 2 subnets, 128 and 192. Let's just quickly do them. So 192.168.10.128 would be the network address and 191 being the broadcast address. The first host address will be 192.168.10.129 and the last will be 190. Then we have 192. 192.168.10.192 is the network address and 255 will be the broadcast address. The first address will be 10.193 and the last will be 254. So each subnet will give us 62 host addresses. We have 54 host devices, so this is probably the best configuration for us. If we were to add another bit to the host address, making the subnet mask /27 or 255.255.255.224, we would not have enough addresses. So just a quick maths. So currently we've borrowed 3 bits from the host portion. So the binary is 8 ones in the first 3 octets, and then 3 ones in the 4th octet, followed by 5 zeros. 3 binary ones equate to 224. 2 to the power of 3 is 8, so we can have 8 subnets. But how many hosts within those subnets? Don't forget, we need to fit in 256 addresses in that space. In the host portion of the 4th octet, we're left with 5 host bits. 2 to the power of 5, or 2 times 2 times 2 times 2 times 2 equals 32. So we'll have 8 subnets, a range of 32 addresses: 0, 32, 64, 96, 128, 160, 192, and 224, split up as 0 through to 31, 32 through to 63, 64 through to 95, 96 through to 127, 128 through to 159, 160 through to 191, 192 through to 223, and 224 through to 255. We have 53 hosts needing IP addresses, so a /27 side notation will not work here for us. We haven't got to use all the blocks we just created. We could just allocate /26 to home, the cameras. But say you had another 50 or 60 devices such as computers, you can allocate them to the second block. So let's put this all into practice. I'm going to log into my Arachnus router. I'm going to create some DHCP servers. I'll add a VLAN ID of 10, and I'm going to call that CCTV. The gateway is 192.168.10.1. When I change the subnet mask to 255.255.255.192 and enable the DHCP server, you see the Arachnus router works out a DHCP range automatically. So it gives us a DHCP scope of 192.168.10.1 through to 62. However, our router is on 10.1, so we just adjust our DHCP pool to what we would like it to be. So I'll do 192.168.10.55 through to 62. And then press apply. Then I'll create another DHCP server. I'm just going to call this one computers and give it an ID of 100. The gateway address is going to be the first usable address we worked out earlier. So 64 is the network address. So our first usable address will be 65, and that's where we're going to place the router. Of course, you can place the gateway at the end of the usable range, but a lot of the time the gateway is the first usable IP address. Then I'll do my DHCP server. The router's worked out the last usable address is 126. So I'll put my DHCP scope to be 192.168.70 through to 126. This gives a bigger DHCP pool for devices such as computers and laptops, for instance. I'll then press apply. Now I'll go to advancing the router and just make sure them VLANs are assigned to a port on the router. And then I'm going to quickly go to my switch and assign the VLAN trunks and access ports. I'll set port 7 to be access for VLAN 10. If I head over to my Windows machine and do ipconfig, we see the gateway of 192.168.10.1 and a subnet mask of 255.255.255.192. And my host address is 192.168.10.55. I'll then assign port 7 to VLAN 100. Go back to the Windows laptop and redo an ipconfig, and we'll see the IPv4 address of 192.168.10.70. The gateway is 192.168.10.65, and a subnet mask of 255.255.255.192. Subnetting is the best method to preserve network resources, especially if you have a big network. If you have an enterprise network with the standard accounts, finance, HR, management, and so on, and they're only made up of 10 people per team, you could work out the minimum number of host addresses and assign them hosts to that subnet. If you then had one department with 10 hosts and another with 100 hosts, you then create more subnets to accommodate the amount of devices. Before we move on, let's work out what subnet and IP address is allocated to. So if we had an address of say 166.243.12.78/28, what subnet would that address be associated with? So the first we need to do is work out a subnet mask. A long way to do it is to write out 28 binary ones. You could look at the side notation and think, okay, so /24 is 255.255.255.0, made up in binary as 8 binary ones in the first 3 octets, and then 8 binary zeros in the 4th octet. We have a /28, that's 4 additional binary ones. So you can add that to the 4th octet, and that might be a bit of a quicker way. There's also 7-second subnetting and magic numbers, which are again a really reliable way to work out subnets. If we add the 4 binary ones to the 4th octet, we get a binary total of 240. So that's going to be our subnet mask. 255.255.255.240. We have 4 host bits available. 2 to the power of 4, or 2 times 2 times 2 times 2 equals 16. Therefore, we have 16 addresses per block. And because we're using 4 network bits, we do the same calculation. 2 to the power of 4 equals 16. So we have 16 subnets and 16 addresses per subnet. Don't be put off by the IP address if it's not 10, 172 or 192. It's just a number at the end of the day. So you just use the same techniques. So because the first, second and third octet is a block of 255, we just use the same network values of the IP address. Don't forget, block of ones or 255 basically means this must match. So our network portion is going to be 166.243.12. Now we need to work out where this IP address sits. The host address is 78. If we remember, our subnet is chopped up into blocks of 16. So we have to put 16 into 256. That's 0, 16, 32, 48, 64, 80, 96, 112, 128, 144, 160, 176 and so on until we get to 256. Our host address is 78 and it falls between 64 and 80. Now we know this, we can work out the subnet address in space. The first number below 78 is 64. That's our network address. 166.243.12.64. Broadcast address is the next block at -1. So 166.243.12.79. That leaves the first and last usable addresses. We add 1 to the network address and -1 from the broadcast address. So 166.243.12.65, and the last usable address will be 166.243.12.78. Now let's look at the other end. We've done subnetting, chopping networks into subnets to better preserve resources and avoid any wasted IP addressing. Let's look at supernetting. If you are planning a network and you have calculated the amount of potential hosts on the network, which exceeds the usable host range, then you might want to do supernetting. So let's say you have 430 hosts on a network. Now /24, 25, 26, 27, 28 and so on, side notation reduces the amount of hosts on a subnet. We want to now go the other way. Let's get straight in and work on the best solution for this situation. We're going to work with a Class C network again, which by default uses 255.255.255.0 subnet mask. Class C addressing is an address starting with 192 up to 223. However, for private internal routing, so not on the public internet, we use the address 192.168.0.0/24, /24 being 255.255.255.0 subnet mask. There are a few other classes. Class A are addresses from 1 through to 126. However, only 10.0.0.0/8 is available as private addresses. The address space there is 10.0.0.0 to 10.255.255.255/8. This gives us a subnet mask of 255.0.0.0. Class B uses a range from 128 to 191, but 172.16.0.0/16 is the available private address. The address space available to us is 172.16.0.0 through to 172.31.255.255. And Class C ranges from 192.168.0.0 through to 192.168.255.255. Between Class A and Class B is an address, so 127.0.0.1. This is an unusable address. This is for loopback and testing. You then have class D, which is multicast addressing, and class E, which is reserved for research and development. So let's look at increasing our usable hosts on a subnet. You'll see on a 172.16.0.0 network, there is a /16 side notation. This equates to 255.255.0.0 or 16 binary ones. This gives us 16 host bits available. 2 to the power of 16 is 65,536. So we can have 65,536 addresses on that subnet. We'll scale down a bit from there. You could use 172.16.0.0 network and add a side notation, so /17 or 18, but then you're subnetting rather than supernetting that IP class. We're going to supernet a class C address, so let's take 192.168.10.0 as our example. We've counted 430 hosts on the network. We need to accommodate the hosts on a single subnet. Let's start with a /24. 24 network bits are being used, leaving 8 host bits. 2 to the power of 8, or 2 times 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 2 equals 256. So that's not enough. Let's add more host values to the subnet mask. So if I set the subnet mask to have 23 binary ones, or /23 side notation, and 9 host bits, 2 to the power of 9 equals 512. 512 addresses in the subnet mask, that's going to work for us. Because we're adding host bits, we work from right to left. So the value of 7 ones with a 0 is 254. And because it's in the third octet, that makes our subnet mask 255.255.254.0. So let's work out the network, broadcast, and first and last addresses in this space. A network address would be 192.168.10.0. A broadcast address will be 512 addresses away. Half of 512 is 256. 0 to 255 is a count of 256. Remember, 0 is a value. When we get to 255, we then start again, but move to the next contiguous subnet range. So 192.168.11.0 and go 256 addresses from there to 255 again. Again, remembering 0 is a value. Our broadcast address would be 192.168.11.255. The first usable host address is +1 to network address, so 192.168.10.1, and the last address is -1 from the broadcast address, so 192.168.11.254. This gives us 510 usable host addresses on this network. You could therefore set static IP range to be 192.168.10.2 right up to 192.168.10.255. Then the dynamic range to be 192.168.11.0 up to 254. Let's now put this into practice. I'll go to my Arachnus router. I'll now adjust the CCTV LAN and change the subnet mask to 255.255.254.0 and adjust the DHCP pool to be 192.168.11.0 to 192.168.11.254 and click apply. If I head to my Windows machine and do IP config, you'll see my laptop has been placed in the 11 range on an address of 192.168.11.0 and the gateway is 192.168.10.1 with the subnet mask 255.255.254.0. Plenty of addresses for the amount of hosts on this system. Let's do another example. Let's say we had 3,000 hosts on a single network. We need to work out what the subnet mask would be. So starting again at 255.255.255.0 or /24 in side notation, which is 8 binary ones in the first 3 octets and 8 zeros in the 4th octet. We count the values in the host portion, so 8 zeros, 2 to the power of 8 is 256. When we add host bits into the network portion, again, work from right to left. We add a 0 to the 3rd octet, that's 9 0 values in the host portion. So the subnet mask will be 23 binary ones and 9 binary zeros. 2 to the power of 9 is 512. This is what we did a moment ago. Let's keep going until we have enough addresses to cover over 3,000 hosts. Let's keep adding a value of 0 to the host portion using the powers of 2. So we have 6 binary ones and then 10 host bits. 2 to the power of 10 is 1,024, not enough. Then we can increase it more to have 5 binary ones and 11 zeros. 2 to the power 11 is 2048. Nope, we are getting close though. So we can have 4 binary ones and then 12 host bits. 2 to the power of 12 is 4096. That's enough right there. So our subnet mask will be 20 binary 1s followed by 12 zeros for the host bits. The network bits add up to 240, or as I said, /20 side notation. This will make our mask 255.255.240.0. So let's work out the IP address in them. Network broadcast first and last. So the network address will be 192.168.10.0, that's a given. In the third octet, we have 4 network bits. 2 to the power of 4 is 16. So we have 16 networks containing 256 addresses. 256 times by 16 is 4096. So our network address will be 192.168.10.0. As I said, that's a given. Then we need to include 15 more networks with 256 addresses. 192.168.10.0 is a count of 1. If we go 15 more times, that would be 192.168.25.0. So our broadcast address will be 192.168.25.255. First usable address will be 10.1, and the last usable address will be 25.254. That gives us 4094 usable addresses. Let's put this in the router. I'll edit my DHCP server on the CCTV LAN, set the subnet mask to be 255.255.240.0, and adjust my DHCP pool to 192.168.11.0 to 192.168.25.254 and press save. Oh, it appears there's been a problem with my config. This is something you might run into. When you are supernetting, the rule is you need to build your networks in multiples of the number of networks to be created and aggregated. So, to get 4096 addresses, we need to aggregate 16 networks. So the first network will be 0 through to 15. Don't forget, 0 is the first network. 10 is not a multiple of 16. Then 16 through to 31, and so on until you get to that 256. If we are to use this network size, we either need to start the network on 0, 16, 32, 48, 64, and so on. So it would be 192.168.0.0 to 192.168.15.255. Let's adjust my router. I'll change the gateway address to 192.168.0.1 and put the subnet mask as 255.255.240.0. I'll set the DHCP range to be 192.168.13.0 through to 192.168.15.254. I'll click apply and it's now accepted the change. I'll head to my Windows machine and do IP config. And we can now see the gateway is 192.168.0.1 and my laptop is on 192.168.13.0 with a subnet mask of 255.255.240.0. So for this configuration, my network address is 192.168.0.0. My broadcast address is 192.168.15.255. My first usable IP address is 192.168.0.1 and my last usable IP address is 192.168.15.254. I hope this video has explained the configuration of subnetting and supernetting. I do find it fascinating, but when I first began subnetting, I was completely lost and it took me a while to grasp it. Of course, there are online subnet calculators you can use, but it's good to know the raw maths to working out subnets.